So I'm a controls guy, automation guy, PLC guy, software guy, and some other funny names I've been called as well. But anyway, and this is basically what I do for a living. It's electrical control systems, PLC systems, something revolving around some logic control. So in front of you have Alan Bradley, Logic's designer in this case. This is a brand name in the industry, one of the better known, easy bit of software to use, very intuitive, window easy type of intuitiveness with it. So I want to talk about some of the one of the programming styles or software styles that I see out in industry quite a lot, and or design pattern is probably the better term for it to be called, and basically the pitfall of this pattern, and I see a lot of it in industry, and it's basically a lot of software that you look at that's a mess is usually because of this particular design pattern, and I see it a lot, and people use it almost all the time when they design a machine. Well, not all the time, but a lot of times. So a very sort of inexperienced software guy will use it, and sometimes, or most often, even the most experienced guy will use it. He's just the way he writes software, basically. So typically we have two sections in the PLC. One is driver and one sequencer. Maybe it's not exactly the same name, but that'd be the name that I'm using over here. So sequencer is obviously the sequence section, and the drivers is obviously the driver section that drives a physical output or some communication, bit of message, data package over whatever communication protocol, Ethernet IP, Profinet bus, EtherCAT, whatever, one of these, RS485, or whatever. So one of these things. So let's try and keep it short and simple on our sequencer. So we have a sequencer, and let's go for the first step in the sequencer, and so this is how they typically would start out. And let's say it's push button, motor. As you can see, I've done a little bit of prep work. Motor start, and they latch something over here, and we call that step 0. Right? So that's the first step in our sequence. Then they'll come along with the next step here. So that guy obviously goes here, and then maybe we have a motor running indicator. So say motor, oh, there it is, wonderful. Motor running, and that'd be step 1. Okay, and then we might have a motor. Oops, let's try and copy that again. Control C, Control V. Oh, don't want to copy for some reason. C, Control V. Right, with no copies. Yeah. Anyway, what can you do? So that's there, and we call that step 3. And let's say we have a push button to stop the motor. Push button, stop there, STP. Okay, it's very simple. I mean, writing PLC software is actually simple. It's easy. It's not rocket science. So I've just created a sequencer over here, and we can make it a little bit more clearer. So if you're a guy that writes software, learning, so that's motor, start. Oops, start. Push button there. Push button. Obviously, we describe what's going on there. We don't actually describe the run. And the next one would be, let's say, motor running indicator. Okay. And in this case it'll be a just dot 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 lamp. And the next one would be wrong comment, motor stopper. Motor stop. Okay. Easy, huh? Easy peasy. So these are the sequences, the steps over here. Step 0, 1, and something's not right. 0, 1, and 2. Okay, 2. Okay. So then the naive programmer come along. He would come along. He would do this. He would copy that. He would come over here. He would come to our driver section. Wait for it to update. Running a virtual machine here. Actually, I got this back to front. Actually, this should be in the sequencer section. And right, so now we're in the driver section. So this would be, so on step 0, we want to start the motor. So the motor running. Do I have it here? Here we go, motor starter. It's motor start on step, you guessed it, step 0. Wonderful. And we can make that step 1. And that would be step 2. Delete, and that's motor start, and that's a lamp, so that would be something like motor MTR. Try and keep the naming convention the same, and let's say motor running lamp. And the next one would be motor stop. Motor should be okay. Yeah, okay. So there's motor stop. So there we have it. So we've just created 3 sequences over here, and with the drivers. Now this obviously doesn't work, but bear with me. This is the approach that someone would take to this, to writing software like this. Then he would say, right, so the motor started. So let's go back to front. So we're in this step over here. We're waiting for the push button. So when we're there, when we say stop, because this obviously goes to the driver section, we want to unlatch the running indicator because obviously it's not running anymore. So we'll come over here. Okay, we'll come over here and we'll unlatch that guy. So unlatch, and we'll unlatch that guy over there. There's one. Okay, let's not worry about any race conditions that occur over there. Probably will, but let's imagine that that's the case. This is the case. So he would do that, and then he would say, "Oh, actually, I also want to unlatch that guy over there because it shouldn't really be running at that point." So yeah, come over here and here unlatch this guy here. As you can see, this package is pretty quick to use. This package, huh? The more you use it, the quicker you get with it. So he unlatches that step over here. But then he might say, well, actually, I should have unlatched. When the motor is running, obviously the push start button condition is no longer valid because it's running. So he will probably do something like this. If I can get it to do that. Here we go. You do this, and then he'll just do that, and he'll unlatch it over there as well. So, and so on and so on. And this is how it goes basically. Because then you might say, well, if you're running, well, you're not in the stop condition. He might even do something. If he's a really funky guy, he'll do something like this because he's a bit paranoid of what's going on, and he'll say, "Oh, unlatch step." Two, right? Because obviously, if we're starting it, then we're not stopping it. That's what he's saying. So as you can see, we end up with these latching and unlatching and even double unlatching, and that obviously gets driven in the driver section. Let's not worry about this latching over here. Well, let's worry about that. So essentially he would have to try and repeat that over here as well, if he's gone for this latching mechanism over here. So we'll come back to that. So this is three rungs. You can imagine the combinations of this, of what combination you would have over here. So essentially you could have more or less 2 to the power 3, would that be right? Yeah, probably 2 to the power 3 combinations over here of what's, or 2 to the power 3 less 1 of combinations of what possibly could be happening over here. Now, so you've basically been lured into a false sense of you think this is right, the right way to go, and now you sort of add these caveats to it, and now maybe you realize it if you sort of a little bit tuned into it of where this is going to end up. And if this is your first time writing software, well, then you're probably not tuned into it. Okay. Or if you've hardly ever written software, then this is probably it's the siren call of the mermaid, basically. You've been lured to your fate, and the fate is usually a machine that sits there that's unmanageable because the software is unmanageable. Basically, no one knows what it's doing, and every time someone comes in to correct software or upgrade the machine, it gets worse. Basically, it doesn't get better. And maybe if you're lucky, you get that guy that sort of worked it out. He knows that it's sort of like this, and he understands that it's this step sequence with all this unlatching and latching. He might work it out. He'll work out a little trick how to work, put in software and everything, but only he will understand it. He's the man, basically. So you end up with that scenario. So I've seen machines scrapped because of this. Several machines scrapped because I've seen machines there where they rewrite the code to correct it, and even that ends up a disaster because they rewrite the code and it's just as bad as the first attempt, basically. Some lessons learned, but basically just a mess as well. So one of the ways to get around this. Now, I'm not saying the method I'm going to show of getting around this is not. I mean, I wouldn't start off doing things like this. Is just I wouldn't go down there. It has its place, but on complicated machines and machines that are going to be in place for several years, or for a long time, I don't think so. Because this gets even worse when people add rungs in. You can add a rung in over here. It might be something like this. That'll be, let's call it step 1 0 A, for example. Okay, so you got that, and maybe we're looking at maybe he does this just because and then this step over here would obviously be reflected back into the drivers over here, so we'll put it over here. Maybe a better place is to put it over there, and that would be step 0 underscore A, and maybe that's I don't know, a siren, a motor siren, motor start alarm. Okay, there it is. I'll put it in early on. So something like that, and then again you would have to deal with who unlatches a step or who latches it. So that's the problem. So you've been presented with this problem. It's a headache. So one of the ways to get around this is, let's get rid of all this unlatching stuff over here. So first of all, we get rid of that. Boom, boom. Okay. We end up with 3 rungs over here. So a nice sort of cleanish look about the software. We come to the driver section. Okay. Get rid of that rung. We change this to an OTE. Okay. OTE. And we change, so we don't have to deal with any unlatching over here. So straight away that's now it's quite simple, but and let's say we have a final step in here, an imaginary step called XX step XX. Okay. Right, so step XX. So you've probably guessed it. If you haven't, well, here we go. So if we start, that's where we start the motor, and if the motor is running, that's where we basically unlatch that early on. So it's quite simple. It's not rocket science. This is easy stuff, really. We just come over here, boom, and that will be step 1, and it will be a not condition. Okay? So it's a not condition, and then you come back to the sequencer, and then this one over here. So the motor is stopped, so it's obviously not running. So that one there will switch that one off. So what's that? That's step 2. So just do this, and we come over here, boom, and we again it's examining off. There we go, and that's it. So you can see the pattern here: step 0, step 1, step 1, step 2. So that switches it on, that switches it off, switch it on, switch it off, and etc. 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 Basically, so straight away we've got rid of this unlatching, because latching and unlatching, it happens so fast as well that you won't know who's latching and who's unlatching. That's the other story, and then obviously you have to deal with these latching here, and that's quite simple. We just go bum bum bum, and we just say unlatch, unlatch, unlatch. So whatever the last step is or penultimate step is, that'll be that. And that's it. It's very simple. Yeah. That's yeah, okay. So very simple like that. So straight away you can see it's tidier, and it's definitely more readable because we know exactly where it is over here. And say you end up in a scenario where you want to start the motor several steps later. So it's very simple. You just come over here, okay, and you, whoops, let's not do that. Let's go Control Z. Let's delete that guy. Put that there again. Okay, let's just do it the long way around. Okay, and then we'll end up with something like this. So that'll be step, I don't know, let's say step 10 maybe, and then that's step 20, for example. There you go. So it's much cleaner. And like I said, very easy to do. But obviously this has its problems as well. There's no perfect design pattern out there, and I mean straight away I can tell you, sort of going from step 0 to step 1 is probably a bit of a no-no. You want to maybe say step 0, then step 10, and then 30, and maybe even step 0, step 100, 200, 300, 400. You know, so what? It's just a number at the end of the day. You know. You can have what, 32,000 numbers, so you could make them up in hundreds. You know, it doesn't have to be tens, and then you can add steps in there easier. But like I said, this is not the golden standard of design patterns as far as sequences goes, but it is better than the last one. And the last one I see too much in industry, and the last one ends up as a mess basically. So I hope you sort of glean something out of it, and thanks for watching. Cheers, bye.